Hey you, yes you, how do you use types in TypeScript? Do you do something kind of like this? Nothing wrong with it, right? Well, turns out you may be missing out on a lot of TypeScript goodness because of doing that. Hi, I'm Bosco Domingo, this is Elite Software Engineering, and today I'm going to talk about the use of satisfies and const as two of the best tools that you can use in TypeScript to get a lot of information out of your types without having to dig into the type itself, just directly in your IDE, and it makes TypeScript so much easier to work with. And trust me, I've been using this on everything ever since I learned about it, and I'm so happy that I did. Therefore, let's hop straight into it because trust me, you are going to love this one. Let's say I have a type, my type, very simple, just name and age. I have a function that returns that same type, and let's say I also have a variable with that type done through type annotation. The problem with this one now is if I go to my const, I get information that is utterly useless. I can already see that from the code itself. But at least in this instance, I can go to the reference and see what my type actually is. But if I do this through the function, this is even worse because I can see that this is my type, but what is my type? Like, what does my type actually have? Like, I'm forced to either go to the function to then go to the type, which is 2 extra clicks that should never be needed, or I have to do something like return const in order to find out what even is inside this object. Like that, in my opinion, is something that TypeScript never really did correctly. But the great thing is that they did introduce one keyword that is absolutely fantastic at solving this problem, and that is good old satisfies. What satisfies does is essentially the same type checking and type validation that an annotation does, okay? But it preserves the values if at all possible. In other words, it avoids type widening, and we'll go into what type widening is in a second. But what it does is, with this, we now see that better const has name and age inside them by hovering over it. We don't need to actually visit my type, but we still get the same validation. I now see that if I try to access a last name variable that isn't in this object, well, I'm going to get an error. But if I try to access a property that is in the object, it's all good. So I'm getting the type validation. I'm still getting all the information of the object itself without having to do anything. Unfortunately, there is no getting around this in TypeScript with functions. There are 2 GitHub issues open specifically for this matter. They've been open for years, but still no way to actually tell this return satisfies my type. TypeScript won't complain about this. You will not get a compiler error, but you still won't get all the good things about satisfies. So if you want to check those GitHub issues, they'll be in the description. So you can upvote them. You can let them know that you're interested in this being also available for functions. And not only for the return type, also for the parameters. So that would be very nice. For now, there's no way around it. So having seen what satisfies does, let's now talk a bit about type widening and why satisfies is so useful. Type widening is nothing more than TypeScript saying, what is the most general type that I have that encompasses this value and all of its potential brethren? So if we have an active string as a literal, it'll grab the string type. With type annotation, we lose in the type. So if I now do an object and I annotate this new type, the problem I get is what we saw before, where I don't get any particular information. I actually have to go to the actual custom object to see its signature. In fact, even the const will be ignored. It'll be overridden. It still is shown as custom object. We will see what const does in a second, but we see that we can change anything at will. There is no IntelliSense, there is no autocomplete. It doesn't have any notion of the keys that do exist in it. Why? Because we're telling it, oh, it can be any string, and the values can be any string or boolean. That's it, that's all we're giving it. So we can even go ahead and add new keys that were not in the original object, which is something that we may want for specific cases, but in others, this may be a problem. With this const, what we're doing is locking in the values. We're essentially saying this is immutable. Please do not change this. So when we do this, instead of as before with type annotation, we're now saying, hey, keep this as a const. Now, what we do see is read-onlys. This will, on the TypeScript level, impede any changes to this value. The compiler will complain. And as you can see, it does not widen the types. It grabs the actual literal. Okay, so we see that key will only have a potential value of value, nothing else. And the same for our Boolean key. We cannot assign to key because it is read-only. And even if it wasn't read-only, the value should always be value, not new value. With satisfies, what we do is we keep the type stricter, while still allowing changes. It's what we saw before, where values take preference over the type. We try to avoid that type widening while still having mutability. What we ask in a way is, do these values fit the type that I'm asking to satisfy without forcing it to be just that type? Object satisfies, we can get the values, except now they're not as with the asConst. They're not just tied to one single potential value. It just says it could be string. Funnily enough, booleans do act weird with satisfies, where you see that boolean is still taken as a literal instead of just a boolean. Not entirely sure why that happens, but just know that. However, we do lose the ability to add new keys, which is something we want. The moment that you say satisfies, it says, okay, this specific type is these two keys of these potential types. That's it. With asConst satisfies, what we're getting is the best of both worlds. We get the type checking of satisfies, and we also get the immutability of asConst. So you can see that this is the way you combine them. asConst satisfies custom object. And what we see now is that this object will have the read-only, it'll have the literal values, and it'll still have type checking. So if we tried to add this number, we see you can't do this. Whereas previously before, if I now added here other 1, 2, 3, it allows it to. Why? Because we're only saying this is a constant. It'll be 1, 2, 3, but it's not type checking anything. Now we are. So again, as you see, if we try to add a key that is not present in the object, hey, I don't know about this key. It wasn't here. And even if it was here, well, it just so happens that the key is a number. It's a read-only property and it's a number. You can't just assign a string or assign any value for that matter because we sealed it. We kind of froze it in place with asConst. So what are some uses of this? Why would you want to do something like this? Well, imagine a game where we have directions and we don't want to always have to write, say, up is 0, 100, down is 0, 101, etc., etc. We don't want to have to do this. The thing with this is that you can have property level immutability as well. So you don't have to say asConst for the entire object. You can have it just for the up or down or left or right. And you can see here, up is specifically 0, 100. Everything else is a string. Up, cannot change it. You can't do this, but you can do it for down. Ooh, this could be a problem. Now, if you have the entire object as a const, now we do see these values as we mentioned, and now you see we can't make the same mistake as we did before. Down, up, right, left, they're no longer assignable to anything other than what we've said here. In a way, this acts as an enum, and in fact, it's the way that a lot of people prefer to do enums in JavaScript. It's more, let's say, native than enums, which is a TypeScript specific thing. This will work in JavaScript as well. And thus, as a quick recap before we jump into real-world examples, the colon type, so type annotation, loosens the type. All it does is type checking. asConst adds immutability without type checking. It only says, this is the object frozen in place. These are the only values that we will accept. It's like object freeze, but at the TypeScript level. Satisfies type gets type checking without type widening. And asConst satisfies types gives you immutability plus type checking. I hope that makes it very clear. And we'll jump into real-world examples where you can see why I think asConst satisfies type should be your default unless you need anything from the steps above. And in those cases, yes, the prior options are better suited, but in general, this should be your default. So for our first example, we have a simple API route definition. We have the endpoint that we're going to allow, which is /users and /products, and the HTTP methods that we allow to hit our endpoints, which are a get and a post method. The get route, which would be one of these endpoints, any which one of them, and the method will always be get. Same for the post. Path can be any of the two. The method will always be post, and the payload in this case, we don't know it ahead of time. When we define a route, we're basically saying, hey, all our routes will have a path, which can be a string, and specifically one of these strings, and the method can be either get or post plus a payload. So with a type annotation, what we would get is something like this, where method and path are now protected thanks to the type because we've strictly typed it to get or post. However, the payload, we don't really know anything. Even though it has values inside of it, we can't really access them. Why? Well, because it's got the type widening where we don't really know anything about the inside. However, with asConst, we now get something more interesting. The problem is we don't get type validation, as we saw before. So TypeScript doesn't check this, and we're doing something that is not valid, as well as adding new fields. With a satisfies, now yes, we will get type validation, but we won't really be able to see inside of the object itself. We'll only get string and string, which could already be good enough for the majority of the time. But in this case, we want to actually know what the actual strings are. So we do as const satisfies. With as const satisfies, now you see we can dive into the object all the way down and get the actual values themselves, as well as type validation. And why would you want to use this? Well, say we want to test this, for example. We want to elaborate a set of dummy payloads and requests that we want to send to our application when testing, and we want this to always be the same. We don't want them to be randomly generated, or maybe we want, and we can also do that. But in this case, let's say we always want to use the same dummy values. Well, this way you can, and you can see specifically all the values that will be sent ahead of your test. And the way you could do that is I want to create an app.post where I'm allowing /users, we're creating a new post route and you're defining it in your application. And then with the testing library, you could then send that request to that exact same thing with all these values. And you only have one single source of truth to update everything, and all your tests will still work. That's brilliant, and it's a great way to have a route map as well defined for your application ahead of time. You have one single place where you can configure everything and then go to the specific places where it's being used. So in this case, I could do something like this, where it's create user being used, and I'll have one function that implements for this specific path and this specific operation, and I can see that. Severely limits the changes of context and the navigation that you have to do. Another great case for using a satisfies const is when using configurations. In this case, we know we have a set of features that we may want to enable for our application, and we can have even some metadata for that application. As you can see, these are fairly generic. However, if we do type annotation, we've now defined a specific set of features that we want to enable for our app, and then we also have the metadata for the application itself, when it was built, the base URL, say this is an API, the version, etc., etc. The problem is we do not have autocomplete here. We need to know what the features are ahead of time, because config doesn't tell us. It's just record string of boolean. We don't know which features are enabled for this specific build. Also, with metadata, same thing. We don't know which of the fields are inside of it. We do not get type completion. Now, if we use as const satisfies, same thing, same config, same everything. The object itself is the same. However, we now do get validation. We get auto-completion, and we actually can see even the values themselves, right? Analytics is false. We know that beta features is true, and we know that dark mode is true. I can't change them because they're as const, so I can't say, hey, I want to disable this. It's a read-only property. That's thanks to the as const. And I can also get base URL. I know that although this may be undefined, I can still see into them. Isn't this great? I think this is awesome. And even for process.env variables where they are not known until runtime, this is a runtime variable, I still can see that it'll be either string or undefined. So I know that it'll exist, and I know it's either undefined or it'll have a value, and I can check that. And TypeScript will complain if I don't check it, which is great. And last but not least, in the same vein, this one is a bit more front-end focused. Let's say we want to define a set of themes for our application. So we can have a spacing value, be in rem or pixels. It can be, you have theme colors, which are the primary, the secondary, danger, and success. These are the ones that we've defined. Same for the spacing itself. We can have breakpoints, and we can define our own theme. So we can define all our sizes, all our everything in one place, and just reuse them everywhere in our application. And if in the future we need to make any changes, we'll be able to change it in one place and everything will respect it. So how would we implement this? Very easy. We define our primary color. We say our secondary color, danger, success, etc. What is the spacing for each one of them? What are the breakpoints? Now, the problem with type annotations is we go here and all we get is, great, it'll be defined as a hexadecimal, as RGB or HSL, but doesn't really tell us much else. It's not the specific value. We don't know what the actual primary color for the theme is. Same thing with large. Large, well, it's a spacing value. Great, but we don't know which one. Whereas if we do use as const satisfies, in this case, we get all the type validation, and we get the values as constants themselves. So when you actually go and check the primary, you get the actual value of that primary. And the same thing for large. You see that it's 2 rem. So this can be extremely useful, again, to have one single source of truth for your design, where you just reuse this everywhere in your application. If you ever need to make a change, it's easy to do, and you still know what the actual value is without having to go to that single source of truth. So this is extremely handy if you're doing front-end stuff, where you need to keep that coherence across your design without needing to either copy, paste the same values everywhere, or have to go back to wherever you've defined your theme and see what the values are. And all of these examples, as well as from all of my other videos, will be in the GitHub repo, in the description, and in the pinned comment. So feel free to check it out yourself. So you can copy, paste, you can reuse this as you wish. The idea is that you start using const satisfies and you see why it makes sense. Last but not least, I wanted to touch a bit on the limitations of satisfies and const. The very first one is that you can't use const on dynamic data. Makes sense. Const can only be applied to enums, strings, numbers, booleans, arrays, object literals, things that are defined at compile time. So to ISO string or even new date cannot be a const simply because this is dynamic. This will be defined at runtime. And let's say extension of this is external APIs. Same thing. When you do a JSON parse, this returns unknown really any, because it doesn't know what the API that you're calling will return. It's impossible to know. They are dynamic. It is decided at runtime. So we can't do any const with this kind of response. A potential workaround specifically for APIs is to use runtime validation libraries such as Zod, Typebox, Typea. There's a lot of them that you can use. And you would have to do something like this, where you define the object with Zod, and then you parse it using that runtime validation library. But this requires external things. You can't just rely on TypeScript itself. Another limitation, arrays become read-only, and in fact, they technically become tuples. This means that in this case, for example, say we have this config with const, we now only have 3 possible user types, which are admin, regular user, and guest. This means if we try to push a new one, we'll get an error. You can't do that because allowed roles is now read-only. And in fact, you can't even reassign stuff because at property at 0, you have admin and you can't change that. The solution would be to just use satisfies. In this case, you lose the ability to know what is inside. You could do, if you do a const at the property level, again, you get the same problem because you can only accept certain numbers, certain properties. Same thing. You can't really use const in this case if you want that mutability. Alternatively, you can always use type annotation, but if possible, use satisfies. And very much in line with the whole dynamic data thing is competed property names in the end. And in this case, I've used the type annotation on purpose. So we know that key will be a string. We don't know which one necessarily. So when you actually check the object, what you see is, well, something that's quite weird. It's just key. Okay, we know that it'll be that variable, but we don't know what the value of that variable will be. So that's the problem with const, right? If I did remove the string here, then key becomes a literal, and in this case, fairly easy. Okay, we do know that it'll be dynamic key, but if we don't necessarily know this, you see, still, even though technically we already know it. Why? Because, well, key it's a variable. It may change before we actually access it, so we get that same thing. We at least get the fact that it'll be the variable key that will define the name, but we don't necessarily know at runtime what value it'll have. And the one I mentioned before earlier in the video, it doesn't work with functions. Even though I've defined my API call type, which is something that receives no parameters and returns a promise of API response, in this case, it doesn't work. Satisfies is shown as an error, and we have no way to actually satisfy. And you can see that we have an extra field that the API response doesn't have. We're missing the username, and there's nothing complaining about it. It's just saying, hey, you can't use satisfies here. So quick TLDR, by default, use const satisfies. You can always use const for the specific properties themselves. It doesn't have to apply to the entire object. So remember that as well. And if you need, or you're working with dynamic or external data, then yes, use type annotations, satisfies by itself. You need mutability, same thing. If you're working with computed values, then same thing. And using satisfies for functions doesn't work. So that's the limitation in TypeScript's end. With that said, that's going to be it for me now. I hope you liked this video. Do subscribe if you want more of this. Check out the playlist that I have for JavaScript and TypeScript. There's plenty more tips waiting there for you. I'll be coming up with new videos, hopefully every week. I can't promise anything, but that's the idea. So yeah, go ahead and subscribe, leave a like on the video. And remember to always think, design, and then code. And of course, don't forget to have life too. I'll see you guys in the next one.